Welcome to this video. Today we will be building a fighting game using JavaScript and the Kaboom.js library. This video was inspired by another YouTuber educator who's called Chris Codes, who did the same game in vanilla JavaScript and using the HTML canvas element. But today we're going to use the Kaboom.js library, which is a very easy to use library for making games. So let's get started. So first, if you look at the description of this video, you'll find a link towards an itch.io page, which will contain a starter template for the project that you can download and start from there. So first, I'm going to go over the folder structure. So I'm assuming you're using either VS Code or another editor, so I won't go over this. I assume that you know how to use a code editor. I'm using assets that also come from itch.io. I'll put the link of those in the description. However, if you download the starter template, you don't need to download the images separately, as I have already put them into an assets folder. So basically the folder structure is this. So we have an assets folder which contains all the assets, and within that assets folder we have a background folder which contains the two layers of background we're going to use. Then we have an index.html file and then a main.js file. So let's get started and go fill in the index.html file. So if you have downloaded the template, this should already be done. So you can see the code for the HTML file on the screen. And what we're going to do is basically you can rewrite the same thing and then add a script tag to point towards the main.js file, which is at the same level in the folder structure. Once you have done this, we're going to import the Kaboom.js library. So I'm using version beta 2 of the Kaboom 3000 version. So Kaboom has multiple versions that works in thousands. So Kaboom 2000 was the previous, which is the current stable version, but the 3000s brings in a lot of new features that are going to be very useful. So I've decided to use the 3000 version even if it's not yet released fully. So by copying this link, the script tag above the main.js file script tag, you can have access to the library in your code. So this is the simplest way to use Kaboom.js. Now you can copy this and put it, it's important to put it above the main.js file because that way we can access the various functions that Kabooms provide in our main.js file. Okay, now assuming that you're using VS Code, when developing games in JavaScript, you often need to start a local server. So there are many ways to do those, but I'm going to just cover how to do it in VS Code. The simplest way I've found is to just go to the extensions marketplace, then type in live server and install that extension. What it will do is create a server for you very quickly using just a click of a button. Now, if you go back to your project and select the index.html file and then go to the bottom right corner, you'll see a go live button. Click on that button and then you should be able to see a new tab open in your browser with the code, with the changes that are going to appear there. So to test that everything is working all right, we can start by writing Kaboom, then parenthesis, and then an object inside, and specify a width, a height, and a scale. So the reason I'm using the scale to 0.7, just so it doesn't take the full screen. So it's easier to have a bigger view of what is happening. Because if I were to not use the scale param here, it would take too much space in my dev environment. So really, you don't need to use the scale here. So depending on how big your screen is and how you structure your development, it's optional to follow this. So now you should see a checker. So if you save your file, you should either refresh or go back to the browser tab. You should see that you have a checkered board, which is basically the default Kaboom background. So this proves that you were able to successfully init the Kaboom.js library, and therefore we can start making our game. Now, the first step is we're going to load some assets. So to load an asset in Kaboom.js, you can use two things, the load sprite function and the load sprite atlas function. So the load sprite function is good for single sprites. So for example, the background, we can directly point it. So the first param is the name that you're going to use for this sprite in your code. It's a string. And then the second param is the path in your project to find this image to load it in your game. Now, you can copy this code over. What I want to put the attention towards is really the load sprite atlas. So we have this is very useful for tile sets. So when you have multiple tiles in a single image and you want to be able to separate them out and have them as a single sprite, so you can basically draw later on the level. So I have done the job to find out which params to use for each of the tiles we were going to use. So we have ground golden. You specify the X and Y value of where those tiles start in the image. So this is a trial and error process. You have to, depending on what tile set you have to play around with values to see which will give you the correct result. Then we specify the width and the height of the sprite. So because there are 16 by 16 tiles, we can just specify width as being 16 and height as being also 16. Now, once you have this done, we can continue. So we will load the sprite for the shop. So there is a shop in the background, as you may have noticed in the project. So the interesting thing here with this sprite is it's animated, and it will show you how to basically specify animations in a Kaboom.js project. So let's look at it in more detail. So the load sprite, same thing, but this time it takes a third parameter, which will basically is an object which contains slice x and slice y. Slice x is the how many images are there horizontally in that, how many sprites there are horizontally in that image. And for the shop, there is 6 frames. And slice y is the same thing, but vertically. And there is only a single row of sprites. So we can just specify slice y as being 1. Then we have the anims property, which is an object, and inside you're going to specify your animations. There's only one animation that we can have in this shop. This shop animation is the only one, so I just named it default. You can name it however you want. And this is also an object which will need to specify the from property, which is where does the animation start. It starts at frame 0, where it ends at frame 5, and then the speed of the animation and if the animation will loop. So once you have specified all of this, we are ready to play that animation later on. Just want to specify one thing, that if you have 6 frames, the frames count starts at 0. So that's why it's specified from 0 to 5 and not from 1 to 6. So keep that in mind. Now we have the same thing for the fences and the sign, but this time there aren't any animations, so we load the sprites like we would usually do. Okay, now has come the time to load the sprites for our characters. So the player 1 will be the player on the left side, which is a samurai with a hat. And the second player will be the blue character on the right side, which has the red mask. Now to load the sprite, it's the same thing. I'm not going to go over the code, so you can see it, you can pause and copy it. So basically it's the same thing as the shop. This time around we just give unique names to each of those animations, and voila. So if you take the time to just look at each of those images and how we sliced them, you will easily understand what is happening. Now some of those animation, I have decided to loop them to activate the property loop equals true, but for some of them I decided against it because we don't need to loop them. So that will become much clearer when we will actually use those animations. So the same thing now for player 2 as you have done for player 1. There might be some differences, so you can pause here and copy that code, and voila. Now Now let's start actually coding. So for the first thing I'm going to do is to create a scene in which we're going to make our game. So Kaboom has the concept of scenes, which is very useful. So you can go from one scene to another or go back to a scene. For example, when one of the players is going to win, we would like to, if we press enter, to go back to the game. So by having a scene called fight, we can go back to it later on. So I've decided to name the scene fight. So how do we create a scene in Kaboom? We use the scene function. The scene function takes as the first param a string, which is the name of the scene. The second param is a function, which will contain the code for that scene. So we will put the code within that function. Now, when you create a scene, you must have a default scene. So right below the scene function, you can use the go function to go to a specific scene. So we'll go to the fight scene by calling it using the string name of that scene. Now we're going to put our first sprite. So nothing too different should appear in this on the screen right now. You should still see the checkered board, but this time around, we're going to add something. So I'm going to create a variable or a constant called background, and we will use the add function. So Kaboom allows you to put sprite on the screen by using the add function. The add function takes in an array as a param, which will contain components that are going to be used. So there's really this aspect of each game object contains components. So it doesn't only display sprites, but it creates a game object. So here we're effectively creating the background game object. We first start by using the sprite component. So the sprite component is a sprite function called with the background, which is the key or the sprite's name that is going to be used. Now you should see at the top left corner the background, which is too small. So we have to fix this. To fix this, we can use the scale component. And the scale component is basically going to make your image, your sprite, bigger. So here, the value I've decided to use is scale 4. So the scale is going to take the param, which is the value to scale. So I've decided on 4, which is going to look better now. So now the background is fully covered using the trees, the background layer, the first background layer. Now we're going to add the trees, which is the second, the background layer on top. So there's 2 layers in the background. There's the background, which is bluish. And then there are the trees which are more prominent at the front. So to add a child to a game object, so you can do that in Kaboom. This is a new addition to the Kaboom 3000. Before you weren't able to do something like that. So what you're going to do is simply have the background. So the reason I created a constant is to store the game object. So the add functions creates a game object and returns it. And this is handy because now we can just use that game object and use the add function on it. Using the add function this way will add another game object as a children to that first game object. So here we're going to use the sprite trees, and it's going to add the trees, the tree sprite, to the background, the original background, to the first game object. So now you should see nicely that the front trees are going to appear. Now we need to draw the ground. And to do something like that, we're going to use the add level function. So here I've decided to again create a constant, which is going to be called ground tiles, and then store in that the game object. So the add level will return a game object that we can then use to scale upward the tiles. So because now if we create a level using the add level function, it's going to be really small. So there is really 2 options you could follow here. Either each of those tiles are going to be scaled at 4 times to be to look right. You can do this later for each tile, or you can just do that for all tiles using the use function down below. But let's go over the code first, and then you'll have a better understanding. All right, so the add level function has 2 big params. The first one is an array of strings, which is used to define or describe the layout of a map or level. The second param is an object which contains a bunch of properties required for the level or map to be drawn on the screen. So really, in Kaboom.js, to draw a map or make a map, you use strings and not a third-party software like Tiled. This comes with a bunch of advantages and disadvantages. I'm not going to cover that, but for our purposes, this is fine. So let's go over the specifics of this. So I'm going to focus more on the second param. So the first param is really just a layout. You can play around with it and see what happens to get a better understanding. It would be much more effective this way to learn how to structure your layout. But anyway, let's go to the second object, second param. So we can see that there is a tile width property, a tile height property, and those two properties define the height and width of each tile described by the array of strings above. Now we have a tiles property, which is going to define which symbol or character creates which game object. So the tiles property is really the most important thing here. So you can decide to use whatever characters you'd like. I decided to use hashtag for the golden ground and a dash for the ground silver, and then a D for the deep ground. You could use whatever you want. The only thing to keep in mind is to make sure that the symbols you decide to define in the tiles property are the ones used to draw your map or define your map in the array of strings. Now, if I focus a bit more, you could see that we have a sort of an arrow function that creates the game object. And here is where you define which sprite you're going to use. And so I used the sprite component here, using the sprite I wanted, so the ground golden, for example. And then we have the area component. So the area component is really useful for creating a hitbox around your sprite. So this is usually it's automatic. So you just add the area component, and then it draws, it defines a hitbox for your object. You can actually enter some, there are some params you can use inside of it to specify a different shape if you want the shape to be different than the drawing's shape, width and height. And then we decided to use the body component. This is useful because the body component is really what will enable collisions on our game object. I decided to use the isStatic prop, so isStatic set to true, so that Kaboom.js knows that this ground is really static and not affected by any gravity. So once this is done, I decided to scale the whole tile map by 4 for it to fit the screen. To do something like that, you can see the last line here. It's ground tiles.use, and you're going to see this a lot. The .use function is used to add a component to a game object after it has been initialized. So far we learned that to create a game object, we use the add function, we specify in an array a bunch of components, and then we have our game object. But the use function allows us to, after having declared or created our game object, to add new stuff or replace or modify existing components. So here we use the scale 4 component to apply it to our ground tiles. Now the next thing I did, you can have your array of strings more compact. So I just took all the empty strings and put them on one line. You can do that if you want, but it really is just optional. So now if we look at the result, you'll see that we have our ground, which is perfectly drawn and ready. We're ready basically to start working on our players. Actually, before that, we're going to put some other stuff in the background. So a shop and some signs and fences to be really close to the original tutorial that I'm basing this off, which is the Chris code tutorial using vanilla JavaScript. So now, once we have this, we're going to create a shop. So now we can continue and refer to the background game object. So we're going to add to that game object another child, which is going to be the shop. But this time around, I'm not only going to use the background.add function, I'm going to store the result of it inside a constant called shop. So the Components I'm going to use here are the sprite shop, to get the shop sprite, and the position component. So this is the first time we've encountered this component. So the position component, if used for a game object, is used to place the game object where we want on the screen. So you have to specify an X value and a Y value. Here we specify the 170 X value and the 15 Y value. And if you're using this component inside of a child of another game component, the position is going to be relative to that background, to that parent component. So it's not the same if I created this object separately by just using the add function and not using the .add function of the background game object. Now we're going to play an animation for the first time. So to play an animation, you can just take your game object, .play the name of the animation. And if you remember, the default animation was specified when we loaded the sprite for the shop. So that way Kaboom.js knows that the default, what the default name refers to when it comes to playing an animation. Alright, so now you should see on the screen that the animation is working, and that's pretty cool. But now we're going to add invisible walls. So our players during a fight, we don't want them to be able to exit the screen. So either going too much to the left or too much to the right side. So to fix this, we're going to create two invisible walls. And to do so, we're going to use the add functions. So again, add function, an array. This time around we use the rectangle component, so rect component, which is going to create a rectangle. This is very useful for prototyping. So when you prototype, you usually don't want to put game art at first. You just want to test things out with cubes and stuff like that. So having the ability to just draw rectangles very quickly is really handy. So now you can copy the code here, and really there's nothing new here. So I don't think I need to cover up anything. So yeah, I don't need to cover anything here. So you can try messing with each of those. So yeah, I've noticed here that those walls are not invisible. So they're not invisible, they're just not visible to the camera. So they're either a bit too much on the left or too much on the right, just enough so that the player will not be able to exit the screen from either way. Okay, so now we're going to add some fences and a sign. Then again, we add all those elements to the background object, and because the shop and the fences and the signs don't need to do any collisions or stuff like that, it makes sense to add them to the background as children. So here again, nothing new. We use the position component, which I want to make you remember that those are relative to the parent, if there is a parent. If there are no parents, then it is relative to the screen itself. So for example, 0, 0 is going to be the top left corner if it's not a child of a parent or parent game object. Alright, so now you should see that the scene is coming along, and it looks much similar to the final product, so that's cool. Now we're going to create our players. So really, we have two players here, and they're going to share a lot of code. Instead of having to create an object, I decided to just create a function that is going to be called makePlayer. It's going to take the following parameters. So this is something I added, it's not in Kaboom. So it's going to take the position X, position Y, a width and height, a scale factor, and an ID. So for the scale factor param, this wasn't necessary. So you could have hard-coded it to be 4, as the rest of the things we scaled in this game. But, you know, it's good to have some modularity. And I thought at the time I was making this project that I would need to have different scale values, but it wasn't the case. But just to be able to easily follow this tutorial, I would recommend that you use the scale factor. Now here, this function is going to return the add function, the result of the add function. And then again, you have seen a lot that the add function is really key in Kaboom. It's used to do a bunch of stuff, and it's really handy. So really, there's nothing new for the first two components, so position and scale. The area component is going to introduce something new. So this time around, if you use this area component can take in an object with the property shape, and then you can define a specific shape you want using the new rectangle. The vector2 param 0, this is necessary to put it here. It doesn't do anything as I've tested out yet, so really ignore it. It's just necessary in the API for Kaboom. I don't know what it's useful for, but the width and height are important. So you specify the width and height in the constructor for the rect, and this is going to create a hitbox that is specific, that is different than how the sprite of the player is going to look like. Because if we were to just not do any of that and just use the area component without any params, it's going to draw a hitbox that is either too big or not appropriate for the game we want to make. Now, once you have the area component used, you have access to the anchor component, which allows you to draw things from the center instead of the top left corner. So usually in Kaboom and in other game libraries in general, things are usually drawn from the top left corner of the top left corner. So if you want to change that, you use the center. I thought that using the center is much more handy for player characters, and it's easy to reason how positions are going to work if we use that component. Now the other component is we want the body component, so as to be affected by gravity and collisions also, and we want to specify the stick to platform true. This is so that we won't have any issues with when the player is going to collide with the ground tiles and stuff like that. Now another important thing about Kaboom is when you create a Kaboom game object, you can specify or add an object within. So a JavaScript object which can contain a bunch of properties. This is useful because it really allows each game object to have their own data that you can modify later on for that instance. So it's a kind of OOP, but as a component instead of having to create a class. So here I decided to create the property is currently jumping. So everything you see in this object is something that is that I decided to create and is not something that Kaboom needs to work. So this is not defined by the API. So here I decided to have a health variable, a sprite object which contains the name of a key for each of the sprites we're going to use, and then I decided to add to each string the ID. The ID is just going to be player 1 or player 2, so that we will know which sprites to take and display later on. Now, after having created this function, we simply call the setGravity function. So setGravity is going to basically make gravity a thing in our game world. So I decided to use the 3200 value. Later on, we're going to have to lower this, but this is going to apply a gravity of this amount. So really, it's something you just test with trial and error to see which value is going to be more appropriate for your game. Now the important part is now we're going to create our player. So I'm going to create a const player1 equal, call the function, call the various params, fill in the params I need, and then this should display the param on the this should display the game object on the screen. Now as you may have noticed, we didn't specify any sprites, so it's going to be invisible. A cool trick you can do is to hit the F1 key, and this is going to show you the debug mode where you will be able to see the collision, the hitboxes, shapes, and this is very useful for debugging. But now we're going to use the player1.use function and add in the sprite component, and the sprite we're going to add is simply the idle sprite. So player1.sprite. So after you have created our game object, the properties I defined within the game object, the add function, are accessible by just doing the dot nomenclature. So player1 dot sprites or dot health or dot is currently jumping is going to be going to give you the values that we specified in the make player function. So here we want the idle animation. So now you should see that the sprite for the samurai on the left side is going to appear, but he's not moving. There's basically no animation for him. So let's fix that. Now once we have, but before doing any of that, actually let's just, okay, so to fix that, to have an animation, we can add the player.one.play function, and then in params, in parentheses, pass in the idle string, which is going to tell Kaboom.js to play the idle animation. Now, you should see on the screen your player, the first player animating, so moving on the screen, like idle, of course, so not moving around. So now I'm going to create the function run. This is really the reason I'm creating all these functions is because we're going to reuse a lot of code for the second player. So the function run is going to take in the player, a game object, a speed, and whenever or not to flip the player. Flip might sound a bit weird here, but I'm talking about flipping horizontally. So when you go on the right side, we want the animation to play from the right, so to look right, point. So the samurai will point towards the right or run towards the right, and to have the same but the left side, we just flip like a mirror the sprite itself. Therefore, we don't have to create a different animation for the left side. Okay, so if the player.health is equal to 0, we want to freeze the player. So when the player is either going to get killed, or so the only case this happens is if the player is getting killed, so he doesn't have any life anymore, so the health is going to be equal to 0. We don't want the player to be able to move. So by setting this condition, if player.health equal 0, and then return, so basically nothing is going to happen when the player is going to hit the buttons to run. Now we have another condition here, is we want to check if the player current animation. So curAnim is a function provided by Kaboom, which tells you or returns which animation is currently playing. And so if the current animation that is playing is not the run animation, and the player is not currently jumping, then we want to use this different sprite, this one, the running sprite, and then play the run animation. So this way, so that the animations don't interfere. So if what would happen if we would each time set the player animation to run is that it would never complete and freeze. So each time you would click, it would start again from 0, and it would look really jarring. Now the last thing is the two last line of this function is player.move. So move is a function provided by Kaboom. You basically need to provide it two values: the speed at which you want to go, either from the x there, so the x speed or y speed. So we aren't interested in going upwards, so we're just going to provide the speed as the first param and 0 as the second. If you would want to go either on the left side or right side, you would need a negative value for the left side. So instead, if speed was 500 to go to the right, then if you want to go to the left, you would have to provide minus 500. And then finally, we flip the player. So player.flipx, so the .flipx property is something that is provided in Kaboom. So usually to summarize, game objects in Kaboom have their own properties that are in every game object, or every game object that uses a certain certain components, but you can also add properties you want, like we did earlier on with is currently jumping, health, and stuff like that. Okay, so now we have that function. We're going to create another function is called reset player to idle. The reason I wanted to create a function like this is that once the player key releases the run key from either direction, we want to go back to the idle animation. And to do that, we need to just force the player to use the sprite, the idle sprite, and then play the idle animation. So this function is handy because it's going to be used by both players. So that's why I thought I would create it in the first place. Now it's time to implement movement. So to do so, we're going to first use the function called onKeyDown. Be careful with the key down. It's supposed to be in caps, the K from the key and the D from down. Your editor might want to try to lowercase everything, so be careful here, or you're going to spend a lot of time trying to figure out what was wrong. So here, this onKeyDown function is provided by Kaboom. It offers two params. The first param is the key. So it's a string that defines which key the player is we need to listen on when the player is pressing. And the second is a function that is going to run when the key is pressed. So here we want the D key, so to go to the right. So the first player is going to use AWSD for movement, space for attack, and the second player is going to use left key, right key, and up key for jumping, and the down key for attack. Now here, the function we're going to provide is first, we need to provide an empty function, and then inside of it, we pass in the run function with the params we want. So here, player 1, speed of 500, and we don't want to flip the player because he's already pointing to the right. Now on key release is again another function provided by Kaboom. We want to first check if the player.health is not equal to 0, then we reset the player to idle, and then we also specify that we don't flip the player in case the player was flipped. So now if you look at what we have, you should be able to move, see the player running on the right side. It looks pretty cool. Now we're going to do the same code, but for the left side, using the A key this time around, and also this time around using -500 for the speed. So it goes leftward. And also here the difference is that the flip X is going to be true. We want to flip the player. Now if we see the result, we can go on the left side, right side. Looks pretty cool. Now we want the player to be able to jump. And here again, I'm going to create another function that we're going to be used by both player 1 and player 2. Here again, we check that the health, we check if the health is equal to 0. If it is, we do nothing because we don't want our dead player to move. Now we check if the player is grounded. So we only want to be able to jump if the player is on the ground. The reason for this is that if you don't do that, the player is going to be able to jump infinitely in the air and kind of float like Kirby. Now the isGrounded function is provided by Kaboom. So yeah, so this is cool. Just so you know the difference, because this isn't a function I created. Now what we're going to do is we're going to store the current flip value. So by having player.flipX, which is again flipX here, is provided by Kaboom, we're going to store this value to be used later on. This is to determine how the jump is going to look from which side, either right side or left side. Now we can use the player.jump function. This again is provided by Kaboom. So Kaboom provides you a function to handle jumps. So this is pretty handy. We don't have to write any logic regarding this. Then we decide to use the sprite, the jump sprite. Then we flip the player to be in the direction the player was facing before jumping. Then we play the jump animation, and then we set the isCurrentlyJumping to true, the property I created earlier on. Now the function reset after jump down below, well here we want to reset the player to be idle again. But we can't use the reset player to idle directly because we need to do a couple of checks. The first check is the player grounded, and is the player currently jumping? So if the player is grounded, that means the jump was finished. And if the player is currently jumping is true, that means that we need to change something. We need to put the player back to idle. So here we're going to change the property is currently jumping to be false again. And then if the current animation is not idle, which it shouldn't be, so this might be a superfluous if statement, you could try to remove it and tell me if it changes anything, and then you can reset the player to idle. so that when the player finishes jumping, it goes back to the idle animation. So now we're going to implement jumping. So I'm going to use again the onKeyDown function, but this time with the W key for the first player, and then use the makeJump function and pass in the player 1. Now this is where things are different. To reset after jumping, we need to do something new here. So player1.onUpdate. So the onUpdate function is run every frame. And this is important because to know when the player finishes jumping, and we want to set it back to idle as soon as he finishes. So this way, onUpdate on the player is going to call the reset after jump function every frame, or every 60 frame, every frame I think. Not sure about that. But anyway, now you should see that now you can move to the right, to the left, and jump, and that's pretty cool. Now we only have you may have noticed that the player doesn't jump too high, and this is a bit constraining. So you can go back to line 175 where we set the gravity and reduce the 3200 number to 1200, and then test again, and you should be able to jump much higher. And it must be like, so jumping is going to be actually useful and not useless. Okay, now it's time to implement the attack functionality. So players being able to attack. Here again, created another function. I created the function attack. You pass in the player and the excluded keys. So here it's a design choice I took, is that if you press any other key while attacking, you can only attack when you don't press anything else. This is to not have a couple of weird animation and stuff like that. It's a bit of a hack, but if you have time, you can decide to fix this and not use exclude keys and try to make it work so that players can attack while in midair or while running and stuff like that. So here again, I'm just going to walk through the function. The first thing I did was to again check for the player health and prevent anything from happening if the player is dead. The second thing I did was to check for the key. So the isKeyDown function returns either true or false regarding if the key passed in is pressed. So the key here is a string. So the excluded keys is an array of strings that are going to be passed. So you have a for loop that checks for every of those excluded keys. If we find at least one, as soon as we find even one key that is pressed, we return. So we prevent anything from happening, any attack from being carried out. Now here again, we're going to save the current flip so we can use it to direct the attack towards the direction. The reason we're doing this is that when we change sprite, the direction of the sprite pointing might be different from what we currently had in the past. So that's why we need to have the current flip saved in order to apply it again. Now here again, we check if the player current animation is not equal to attack. Only if it is not equal to attack that we're going to run that animation and change the sprites. So we use the sprite for attacking. We flip the current sprite to be the same as the current flip that was before that. This time around, I decided to create 3 variables, /x, /flipped, and /y. The reason for this is we're going to need to create a hitbox, a square or rectangle, that is going to be the area of the attack. So this is going to be invisible, not seen by anyone. That's why we're going to use the opacity component to 0 so that it's not visible. But it's going to be useful because this is how we're going to make to reduce the life points of the second player if he's in the zone of the attack. So I decided to put a player position X plus 30, player position X minus 350, and player position Y minus 200. Reasoning for doing the /x and /y. /x is when pointing towards the left side or right side, the attack, and /x flipped is going to be that same rectangle but on the other side, so that when the player attacks from either the left or the right, the hitbox is drawn in the proper place. Here I tried initially to have a children, the attack being a children, but there are a bunch of issues, so I decided to just do this. So here I'm going to use the add function, create the slash, the radius, so the attack, the square hitbox, so a rectangle by 300 by 300 using the area component. And then for the position, if the current flip is true, that means it's flipped to the right or the left side, then we use the /x flipped position. Otherwise, we use the normal /x, and the /y doesn't change. So really, /x and /y are the position of that rectangle that represents the attack hitbox. Here we're going to use here we're going to use opacity 0 so that the rectangle is not visible, but I want to put your attention to player.id plus attack hitbox. So each game object in Kaboom can have a tag, which is basically a string passed in that array. Here we're going to define a string that is going to be the player ID, so their name or something like that that we're going to pass, that the player has by default. So every game object has a .id property that is defined. And then we're going to append to this the attack hitbox. So for example, if my player ID is 85, it's going to be 85 attack hitbox. The reason to do this is because we're going to be able to destroy that hitbox by using this tag after the attack is finished. So if you look down below, we have player.play attack. And one cool thing with Kaboom.js is that you can play an animation, but you can also specify the behavior, what will happen after the animation is over. So here we have the onEnd property, which takes in a function and it's going to reset the player to idle and then flip the player using the current flip so that we maintain the current direction the player was in. Finally, we call down below, so we have our function and now we're going to use it. So we use the onKeyPress, another function provided by Kaboom.js. This time we pass in the space param and then another function with the attack function being used inside. OnKeyPress space, difference between OnKeyDown, OnKeyPress, OnKeyRelease. So OnKeyDown is really if the key is pressed, and then OnKeyPress just if it's slightly pressed. So we want to press for attack so that at each press the attack animation is played once. We don't want the player to be able to spam attacks by just holding the key. Now we have defined the ADW excluded keys we wanted so that the player cannot move left, right, or jump while attacking. Again, you could decide to just remove this and try to make it work. I haven't, just for the sake to push this tutorial out quickly. But yeah, tell me if you're able to solve this. As you may have seen earlier, we created the onKeyPress with a space for the attack. But this time around, we're going to use the onKeyRelease handler or function from Kaboom. And we're going to use the destroy all. This is where the tag I mentioned earlier on is very useful, because it's by using this tag that we're going to be able to detect the hitbox for the attack and destroy it. So when the player stops press or release the space key, we destroy that hitbox so that the enemy player is not affected by an attack. If you remove this, you might be if you remove this and try to test the game, you'll see that the second player is going to be damaged because you're basically laying attack hitbox around the map instead of having them as attack. So they stick around, and we don't want those rectangles to stick around. We want them to disappear as soon as the attack is done. So now you see if I activate the debug mode, you can see that each time we attack, the box is created, and this is going to be used to determine whenever or not the second player is going to take damage or not. We're going to do the exact same thing, but with the second player. So here's the code. You can pause and look it up. It's basically the same thing. Only difference is that the flip values might be different, the flip X values might be different, and the keys being used are left, right, and down and up instead of WASD. And that's basically it. So yeah, pause if you want. And now I'm going to assume you've paused. And here is how it looks. So we have both our players. They're moving around. It looks really fun. And now it's time to have our counter and our health bars. All right, so for the counter, how things are different. So really, again, we're using the same concepts that I taught you earlier on. So we create a counter using the add function. Again, here my line 339 is not properly formatted, but anyway, ignore this. So just want to mention that we have two new components here. The color component, which takes an RGB value. Now you could have hexadecimal values by writing color and then in parentheses color, capitalized color. So color, the C is capitalized, but the rest isn't. Dot from hex with H capitalized, of course, and then the hexadecimal value as a string. And also you might have noticed the center component function. So the center function is handy because it provides you with the value of the center of the canvas. So you can do center.x and .y and get the x and y value of the center. So this is just for positioning. Then we created the count, which is the text. So here again, a new component, the text component. The text component can take more than just a string. It takes also a second param, which is an object where you can define the font, load a different font. So use a font that you loaded previously and stuff like that. The size, line spacing. I have another tutorial on Kaboom.js that you can see before this one. So look around at my channel and see like the content. I hope you'll enjoy, and feel free to subscribe for more JavaScript content. And now finally we create the winning text component. This component is not a child of anything. It's just going to appear when the game is over, to either say that player 1 has won, player 2 has won, or there is a tie. So this is how the counter looks like. Now we're going to create a variable, a global variable called game over, and we're going to set it to false. Then we're going to use the onKeyDown function again, and this time around we're going to listen to the enter key, and we're going to see to make sure that if the game is over, we're going to go to the fight scene again. So we're going to essentially restart the game. Otherwise, we do nothing. Now I created a function called declare winner, which is going to take in the winning text component we created earlier on, and the player 1 and player 2. This is going to check a bunch of conditions as to whether one or the other player has won or it's a tie. If the player 1 has won, then we're going to display player 1 won, and then use the sprite for the player 2, the death sprite, and play the death animation. Same thing for the player 2. So this declare winner is going to be used when the player is going to be hit and killed, or when the time is left. There is no time left. And really where I want to put your attention towards is the count interval. So this is really the counter. So we create a set interval. So set interval is something in JavaScript which allows you to specify a function that is going to be run a given amount of time. Here it's 1000 milliseconds, which is equal to 1 second. So as long as the count time left is still 0, so if the count the time left is equal to 0, we clear the interval. So we stop running this. So this is to freeze the counter, and not. So if you didn't do something like that, the counter would go to -1, -2, -10, etc., and keep going down, even past 0. Now we call the declare winner function to declare the winner. We set the game over to true. This is so that when the player is going to hit enter, they're going to be able to restart the game. And then we're going to return. So by returning early, we want to run the count.timeleft minus, so reduce the time count, the time left count, or change any text. So now you could see that the counter is going down, and it's tie here in this particular example because you haven't implemented any attack or damage logic. So now we're going to have the health containers, the health bars, that we're going to use to display the health of the player, and then also implement the damage logic so that players can take damage and die. So the player one health container, I'm not going to cover this. It's pretty straightforward. There is the outline component this time around, which creates an outline around a rectangular game object. So that's cool. It's something you can use in Kaboom.js. There's also the rotate component that I'm using to rotate to rotate the health bar. So there is the health container, which is red, and then there's on top of it, as a child, the health bar, the green bar, so that when we reduce the green bar size, we can see the red. And the reason I'm rotating it is because it's going to be reduced from the either the left side or the right side. Anyway, you'll see in the video why in the gameplay. So now we're going to use the onCollide function. So every game object that has an area component can have this function called onCollide. You pass in the tag of the player of the thing you want to check collisions with. So if the player 2 collides with the player 2, if the player 1 collides if the player 1 collides with the player 2's hitbox, then we're going to run the logic that is described here. So if game over, we do nothing. So yeah, so if the player is dead, the second player is already dead, we allow the first player to move around until the game restarts, but they don't do any damage or anything to the first the dead player. Now if the player 1.health is not equal to 0, we reduce the health by -50, and we tween. So this is important. So tweening allows the health bar to reduce smoothly instead of immediately using so this is something really that you should be using to make your game more polished. So this is how it works. So I added the player 1 health bar width, so the green bar, then the player 1.health. So this is the player 1.health is the target value. So something I did here is to have the size of the player health bar to be equal in pixels to the health of the value. So both 500. This makes it very easy to have a one-to-one mapping between the width of the health bar and the health value of the player itself. And then the third param is really how many seconds you want the tweening to take place in. So for example, if I decided to have 2 seconds or 3 seconds, it would take 3 seconds before the health bar reduces to the damage that was taken. This is a bit too much, I think, because the player is going to probably die already. The time it takes for the health to be reduced to the target value. And then the fourth param is a function which is just going to set once the time is up, or gradually set up the player width to be equal to the target value. So so the function is going gradually going to assign the new value, the new width value, to the current width value of the health bar, which is going to be gradually go gradually down. So once this is done, we have another check if the player .1.health is also equal to 0. So the first is if the player health isn't equal to 0, and then now the second if statement, if it is equal to 0, then we clear the interval, we declare the winner, and it's game over. So this is if the player 2 was able to make a killing blow to the player 1. So here, this is how the gameplay looks like. And so now the second player, I think, can attack the first player. Anyway, you'll see in the video right now that is playing right now. Okay, so now we just do the same thing, but this time for the player 2, the second player, the blue one. So here's the code. Copy it, study it. It's roughly the same thing. You can pause here. And voila. So now we have the final game. You can hit in both directions. It's pretty fun. And that's it. So we have a full JavaScript fighting game that is similar to the one who was made in the fighting game JavaScript tutorial by Chris, I think. And that's basically it. Now, before releasing any of this on itch.io or other platforms, you can go back to the Kaboom object we created initially and add in the debug property to be false so that players will not be able to see the debug mode by pressing F1 like we did in development. Now the only thing left for you to do is to zip your source code and go on itch.io and basically upload it there. So thanks for watching. This was a fairly simple tutorial. It took me a lot of time to build, but I'm glad with the result. Hope you learned a thing or two. If you like this content, feel free to subscribe. And that's it. Thanks for watching.